Alright guys, here are your warm-up problems for today. You can work in groups on these. Go ahead and pause the video and try these problems on your own, and then we'll come to it at in a minute here, and I'll give you the answers and work through the problems. So again, try these on your own, pause the video, and then we'll work through the problems. Alright, so here's number one. This one's really dealing with the fact that you have two inscribed angles. Angle ABC right here, there's the vertex, which extends to endpoints here and here, and you've got another inscribed angle, angle ADC, that essentially projects to the same endpoint. So what we know, and we talked about this, and I just want to reiterate this from the other day, we know that these are always going to be supplementary. Alright, so the relationship that we can use is 4x plus 10 plus 7x plus 5 is going to be equal to 180. Go through and solve for x, and you should get 11x equals, that's 15, minus 15 is 165. So x is 15. Oop, I lost my marker there. X is 15. So we've now solved for x, but the problem wanted us to find the measure of angle A, so that's this angle, if dB right here, that arc is equal to 9x minus 25. So first things first, we can figure out that the measure of dB, based on what we just found x to be, the measure of dB is 9 times 15, which is 135 minus 25, so that's 110. We now relate that back to the angle, which would be angle C. So angle C is the angle that projects to arc dB. So dB is 110. Angle C has got to be half of that. So that would be a 55-degree angle. And again, these two inscribed angles right here project to the same endpoint, so we know that they have to be supplementary. So the last piece of this then is to figure out what angle A is, and the measure of angle A is going to be equal to 180 minus 55, which gives us 125. So there's our final answer. A lot of work that goes into that one. Probably not the only way that you could do it, but that's probably the quickest way to do it, was to use the fact that that inscribed angles that project to different endpoints are supplementary. Alright, this one over here, number 2, is just kind of reminding you of one of the relationships that exists, and we'll delve a little bit further into the types of lines that these are. These are tangent lines. So if these lines are tangent, then we know that they project, that they intersect the circle at one particular point, that point of tangency, and we'll talk a lot more about that today. But this is an intersection outside of the circle. So we have two tangent lines intersecting outside of the circle. The vertex is outside the circle, which means if I take the measure of the angle, and in this case the measure of angle B is going to be equal to the larger arc, so that's this guy, minus the smaller arc. So we're going to have a little, I'm going to throw another point on here. We're going to call this point E. So that's going to be equal to the larger arc, which is measure of arc AEC, minus the smaller arc, which we know to be 110. So that's our 110. Alright, so we're going to subtract the smaller arc from the larger arc, and we always divide by 2. The measure of angle B we know is 70 degrees. So ultimately, let me come down here. Ultimately, we're going to get the equation 70 is equal to the measure of arc AEC minus our 110 divided by 2, multiply by 2 on both sides, go through and solve for the measure of arc AEC. So we get 140. We're going to add 110 to both sides, so plus 110 is going to be equal to the measure of arc AEC. So we get 250 degrees, measure of arc AEC.